Okay, this video is to explain how to determine a standard curve utilizing a mathematical formula called Beer's law. Most proteins follow a standard curve is established to determine unknown protein concentration utilizing a graph that of known protein concentration. Most of the time this law, Beer's law, is a bit complicated for most people to fully understand. So instead of utilizing Beer's law, we will utilize a more simple formula that is shown here. So we calculate albumin concentrations for a standard curve knowing the formula that is given down here. And that formula that is shown right here is easily solvable because we first know the initial stock concentration of our albumin, which is represented by C1. We also know the initial volume of how much albumin we added to our test tube. So we also know the value for V1. We also know the total volume that we added into the test tube, V2. So we basically are now going to solve for C2. And we do that by rearranging the variables and solving for C2 as indicated in the formula down below. So we are going to practice how to calculate the standard the calculation of the concentration to prepare a series of dilutions called serial dilutions to determine a standard curve. So here is a sample table to show you that we are starting off with a known concentration of albumin. That known concentration as given, so we know that C1 here is equal to 2.5 milligrams per milliliter. We also know that the volume of albumin that we are adding to each respective tube is also given in this column here. So we know that V1 is given in this table here. So since we know this information, we also know the total volume in each test tube. The test tube contains albumin as well as a buffer. This buffer that we're using is a potassium chloride solution, and so that volume we also know. We also know that we are adding a reagent called Biret's reagent, and this reagent will react with the protein and turn to a purple color. We are using our spectrophotometer to measure the absorbance of this color change. So we know that the volume, V2, is equal to the total volume inside the test tube. And in this case, for tube number 1, the total volume is 8 milliliters because we can add that we added 0 milliliters of albumin, we added 5 milliliters of our potassium chloride, and we added 5 milliliters of Biret reagent. So our V2 value is 8 ml. We do not know what C2 is, which is the column that we are going to calculate here, this column here. So the first one, as you can see, shows that C2 is equal to C1 multiplied by V1 divided by V2. So So to plug in the numbers, we take C1, which is 2.5 milligrams per milliliter, multiply that by volume 1, which is 0 milliliters, and we divide by 8 milliliters. So obviously that equals to 0 because 2.5 times 0 is 0. 0 divided by 8 is 0. If we look at the second column, the second row here, if we look at the second row here, we know that again C1 is equal to 2.5 milligrams per milliliter. We know that V1 in this case is equal to 1 milliliter, and we know that V2 is equal to 8 milliliters total volume. Okay, so we need to solve for C2. In this case, it is 2.5 times 1. I'm not going to put in the units for space, and then that's divided by 8. We do that, we get the value 0.31 milligrams per milliliter. So we can fill that into the table. So that is 0.31 milligrams per milliliter. Okay. So we can continue to fill out the table, but I will not do that in this video. So to review again, we can calculate the final concentration using this formula as shown here. We have to measure the absorbance of these proteins using a spectrophotometer. We can then graph the data with the absorbance on the y-axis as a function of protein concentration on the x-axis. We will then use the standard curve to estimate the concentration of an unknown sample by measuring the absorbance of the unknown sample. So we will show that here. So the table that I showed earlier is now filled out. So this is our calculated concentration in the column that is that I circled in red. I put a red box around. So we have that number. We can then plot a graph similar to the one shown here. If we, so we can plot a line graph and we can do a best fit line such as being shown here. We can also measure an absorbance of unknown protein concentration, extrapolate over, drop down, and use the graph to determine the unknown concentration. So if we know the absorbance, we can go over to our standard curve and then use the standard curve to estimate the unknown protein concentration. So this video is to explain how to calculate an unknown, how to calculate a protein concentration of known value, known protein values, use those values to plot a absorbance, plot a curve, and then you have a standard plot as shown here. So absorbance has to be measured using a spectrophotometer, and we can use the data from the spectrophotometer to determine the unknown protein concentration.